Find the forces in all the members of the truss shown in the figure below. And in this case, we are going to begin with determining the value of the reactions at A as well as the reaction at B. Now, the support reactions at A will consist of both horizontal reaction, that is HA. Therefore, here we are going to have a horizontal reaction, HA, as well as a vertical reaction, that is RA. Now, we are going to begin with the reaction calculations. So we have reactions calculations. And in this case, we are going to take moments about point A. Therefore, taking moments about A, taking moments about A, we are going to have the following. Therefore, we get so this is going to be, we have a horizontal force at joint E, and it is at a distance 1.5 meters from joint A, and therefore we are going to have RB, that is reaction at B, multiplied by the distance from B to A, which in this case is 4 times 3, that is 12 meters, and that is an anti-clockwise moment. So this anti-clockwise moment is equal to the following clockwise moments: 8 times 1.5 meters. Therefore, we have 8 times 1.5 plus, at F we have a load of 3 kilonewtons. Therefore, 3 times 4, 3 multiplied by 4 plus 6, the load at G, multiplied by 8. Therefore, plus 6 times 8. 6 times 8. And this is going to be RB times 12 being equal to 8 times 1.5, that is 12. So we have 12 plus 3 times 4, that is 12. 6 times 8, that is 48. Therefore, the reaction at B will be equal to 12 plus 12, that is 24. 24 plus 48, that's going to be 72. Therefore, 72 divided by 12, that is going to be 6 kilonewtons. And therefore, the reaction at B is going to be 6 kilonewtons. Therefore, we write there 6 kilonewtons. To get the reaction at A, we are going to say that the sum of all the upward forces is equal to the sum of all the downward acting forces. And therefore, the sum of upward forces, we have RA plus RB is equal to the sum of all the downward forces that we have. We only have these two downward forces, that is 3 plus 6. And therefore, reaction at A plus reaction at B, which is 6 kilonewtons, is equal to 9 kilonewtons. Therefore, reaction at A will be equal to 9 minus 6, which in this case is 3 kilonewtons. Therefore, the reaction at A is going to be 3 kilonewtons. We also need the value of this horizontal reaction, and in this case we are going to say that these two forces are acting in opposite directions, and therefore their resultant is going to be 0, and that means that those two forces are equal. And therefore, for the horizontal forces, that is the horizontal reaction at A will be equal to 8 kilonewtons. That is the opposite acting force. So that is 8 kilonewtons. So we have a horizontal force of 8 kilonewtons. Good. After that, after getting the value of the reactions, we are going to determine the value of angle theta. The value of angle theta. And in this case, if we consider this triangle ACF, so considering triangle ACF, let's draw it here. We have A, this is F, and this is C. The perpendicular height of this triangle is 1.5 meters. 1.5 meters. That is the perpendicular height of this isosceles triangle. 1.5 meters. That makes 90. If we call this X, call that X, we want that angle theta. So we have the adjacent and we have the opposite, and that's going to be a relation of tangent. Therefore, tangent theta is equal to opposite, which is 1.5, divided by the adjacent, which in this case will be half of 4, because this perpendicular height is going to divide the base of this isosceles triangle into 2 equal parts, each having 2 meters or a length of 2 meters. And therefore, tan theta is going to be, so when you divide 1.5 divided by 2, that's going to be 0.75. The tan inverse of 0.75 is that 6.87 degrees. Therefore, tan theta is equals, or the theta in other words is equals 36.87 degrees. So all these angles will be equal. All these angles will be equal, and they are going to be equal to 36.87 degrees. Good. So after getting the value of the angle theta, the next thing will be determining the equilibrium of various joints, or considering the various joints to get the forces acting in all these members of this truss. And we are going to have here equilibrium of various joints. Equilibrium of various joints. And in this case, we are going to begin with joint A. So we begin with the joint A. So if I try to plot joint A here, at joint A we have the following. We have an angle theta here of 36.87 degrees. We have a reaction at A. So this is the joint A. This is the reaction at A, which is 3 kilonewtons. 3 kilonewtons. We have a horizontal reaction HA, whose value is 8 kilonewtons. This is joint F, and this is joint C. So if we assume that on member AC we have a compressive force F1, since that member AC, we have named it member 1. Then on member AF, we assume that we have a tensile force F2, since that is our member 2. Now, we are going to begin with resolving forces vertically, and therefore, when we resolving forces vertically, we are going to have the following. So, resolving the forces vertically, we are going to have this F1, converting it to a vertical force. It is going to be F1 multiplied by the sine of this angle, sine 36.87. We add the reaction at A, which is 3 kilonewtons. We equate that to 0, since the summation of all the vertical forces is equal to 0, and that's the principle we are applying. Therefore, F1 is going to be, take 3 the other side of the equal sign, that's going to be negative 3, and then we divide by sine 36.87, and that is going to give us a force of negative 5 kilonewtons. Therefore, the value of F1 is negative 5 kilonewtons. Now, if we ignore the negative sign, we are going to have F1 having a value or a force of 5 kilonewtons, and that means that F1 will be a compressive force. Good. After resolving the forces vertically, the next thing will be resolving the forces horizontally. And applying this principle of summation of all the horizontal forces to be equal to 0. Now, when we solve the forces horizontally, we are going to have F1 multiplied by the cosine of this angle, that is cos 36.87, plus this force F2, therefore plus F2, is equal to this horizontal reaction, which is 8 kilonewtons, therefore is equals 8 kilonewtons. Now, we have the value of F1, which is negative 5 kilonewtons, and therefore negative 5 multiplied by cos 36.8 plus 87, that's 6.87 plus F2 is equal to 8. Now, negative 5 multiplied by cos 36.87, that is 4. Therefore, we are going to have negative 4 plus F2 is equal to 8. And therefore, the value of the force F2 is going to be 8. Taking 4 the other side of the equal sign, that's going to be plus 4, which in this case is 12 kilonewtons. And therefore, the value of the force F2 will be 12 kilonewtons, and it being positive is going to be a tensile force. Therefore, force F2 is a tensile force, just as we have indicated on joint B. The next joint we are going to consider is joint C. So we consider joint C. So from joint A, we go to joint C. Now, at joint C, we have the following. We try to plot it here. This is how joint C will look like. This is how joint C will look like. we have angle theta. Now, if we extend this member beyond C, this angle and this one are going to be equal angles. Is it alternating or corresponding? Whenever. So it means that this angle is also 36.87 degrees, as well as this angle 36.87 degrees. We have joint A, that is joint A, this is joint C, this is joint F, this is joint E, that is joint E. The members that we have member AC, and on member AC we have a force F1, which is a compressive force. Therefore, that force will be compressing joint C. So this is F1. We already know its value. Then let's assume that on member CF we have a tensile force, and that is our member 3, and therefore that is going to be a force F3. Now, on member EC, we are going to assume that we have a compressive force, and that is our member 4, therefore that's going to be F4. That's going to be F4. Now, likewise, just as we have done with joint A, we are going to begin with resolving the forces vertically. Therefore, resolving forces vertically and applying this principle of summation of all the vertical forces to be equal to 0. Now, we are going to have the following: F1 sine 36.87 plus F3, this is F3 multiplied by the sine of this angle, that is multiplied by sine 36.87, that is going to be 0. That's going to be 0. Now, F1 is negative 5 kilonewtons. Therefore, negative 5 kilonewtons multiplied by sine 36.87 plus F3, which we don't know, plus F3 sine 36.87, that one is equal to 0. We are going to have F3 sine 36.87, which will be equal to, the negative sign will change automatically to positive, therefore it will be equal to 5 multiplied by the sine of 36.87. To get the value of F3, we are going to divide both sides by the sine of 36.87. On this side, the same, we divide by the sine of 36.87. Those two signs will cancel out, and therefore we are going to have F3 being equal to, the two signs will also cancel out, and therefore F3 is going to be 5 kilonewtons, and it being a positive is going to be a tensile force. Therefore, F3 is a tensile force. So after resolving the forces vertically, we are going to resolve the forces horizontally. Therefore, resolving the forces horizontally and applying this principle of summation of all the horizontal forces being equal to 0, we are going to have the following: F1 cos 36.87, F1 multiplied by the cosine of 36.87 plus F3 multiplied by the cos of 36.87. So F3 cos 36.87 is equal to F4 is equals to F4 plus this horizontal force of 8 kilonewtons, therefore plus 8. We have the value of F1, which is negative 5 kilonewtons, and therefore negative 5 cos 36.87 plus, we have the value of F3, which is positive 5, therefore plus 5 multiplied by cos 36.87 is equal to F4 plus 8. Negative 5 cos that 6.87 plus 5 cos that 6.87, that's going to be 0, and therefore we are going to have 0 being equal to F4 plus 8, and therefore the value of force F4 is going to be negative 8. When you take 8 the other side of the equal sign, that's going to be negative 8 kilonewtons. Now, ignoring the negative sign, that means that F4, it means that that force is a compressive force. So, ladies and gentlemen, we are done with the joint C. Now, after completing with the joint C, we are going to the next joint, which is joint F. Therefore, we go to joint F, and I am going to plot it here. So, joint F, joint F. So, joint F have got the following members. It has the following members. We have angle theta. We already know theta is that 6.87. On this side, the same. Here we have joint C. We have joint D at that point. We have joint A here, and we have joint G. At joint F, we have a downward acting force whose value is 3 kilonewtons, and that is joint F. Good. So let's assume that we have the following members, the following forces. Definitely on member CF, the force F3 is tensile, and therefore it means that it is acting, or it is pulling a joint F. So here we have F3. On joint, that is on member DF. On member DF, let's assume that that force is compressing joint F. That is our member 5, and therefore this is going to be F5. The force F2 on member FA is, so we are looking for F2, 12 kilonewtons, which is a tensile force, and therefore it is pulling joint F as well. Therefore this is F2, 12 kilonewtons. Then Fg is another tensile force pulling joint F towards this direction. Obviously its value might be 12 kilonewtons. Likewise, we are going to begin with resolving the forces vertically. Therefore, resolving forces vertically and applying the principle of summation of all the vertical forces being equal to 0. Therefore, resolving the forces vertically, we are going to have F3, this F3 multiplied by the sine of this angle, therefore F3 sine theta, plus F5 multiplied by the sine of this angle, so that is F5 sine theta, is equal to this downward acting force, which is 3 kilonewtons. Therefore, that's going to be 3. Now, the value of F3 is 5 multiplied by sine 36.87, because that is the value of angle theta, plus F5 multiplied by the sine of 36.87, that one is equal to 3. Now, F5 multiplied by sine 36.87, that happens to be 3, and therefore 3 plus F5 sine 36.87 is equals 3. Take this 3 this side of the equal sign. We are going to have F5 multiplied by sine 36.87 is equals 3 minus 3, which is 0. And therefore, 0 divided by sine 36.87, definitely that is 0. That makes the value of the force F5 to be equal to 0. Therefore, F5 is equal to 0. Good. After resolving the forces vertically, we are going to resolve the forces horizontally. Therefore, resolving the forces horizontally and applying this formula or this principle, summation of all the horizontal forces to be equal to 0. So this is going to be F2 plus, so we are going to have F2, this is F2 plus F3 multiplied by the cosine. When we are solving the forces horizontally, we multiply a force by cos of that angle. So that is F3 multiplied by cos theta is equal to, here we have F6, this is number 6, so that is F6, so it's equals to F6 plus F5 multiplied by cos theta, that is the cosine of this angle that we have here. Now we have the value of F2, which is a tensile force of 12 kilonewtons, therefore that will be 12 kilonewtons plus F3 is 5 kilonewtons, another tensile force, therefore that will be 5 multiplied by the cosine of 36.87, that is going to be equal to F6 plus F5 cos theta, and F5 is 0, therefore that is equals to 0. Now 5 multiplied by cos 36.87, that happens to be 4, therefore 12 plus 4 is equals F6, and therefore the value of the force F6 is going to be 16 kilonewtons, and that force being positive, that is going to be a tensile force. Very good.